So in this problem, we're trying to find what quadrant our angle X is in. So remember, whenever you're going through a problem where you're trying to find quadrants given trig functions, you need to remember what trig function is positive and what quadrant. So remember our table, we have all students take calculus, meaning in quadrant 1 all of the trig functions are positive, in quadrant 2 sine is positive. Let me write these out. Quadrant 1, quadrant 2. In quadrant 3 t means tangent is positive, and in quadrant 4 cosine is positive. So using this information, we were given that sine of x is less than 0, while cotangent of x is greater than 0. So we're finding what x is being plugged into each of these to make these trig functions less than 0 and greater than 0 at the same time. So let's start with the sine of x. We want to decide what quadrants sine of x, sine of some unknown angle, is less than 0. So if we go to our chart over here, in quadrant 1, all trig functions are positive, which means sine is positive. In quadrant 2, sine is positive, which means in quadrants 3 and quadrants 4, sine is going to be negative. Notice only tangent and cosine are positive in 3 and 4. So we'll make a note here. Sine of x is less than 0 only in quadrants 3 and 4. Okay, so from here, let's move over to cotangent of x. Cotangent of x is greater than 0. Now remember, this chart only works for sine, cosine, and tangent, but cotangent of x is just the reciprocal of tangent. So cotangent of x is equal to 1 over the tangent of x. So let's think about that for a moment. If cotangent of x were, for instance, -1, then that means that if you took its reciprocal to find tangent of x, then you'd get 1 over -1, which would still give you -1. Let's try that with one more to see the pattern that's happening here, because this doesn't make it completely obvious. Let's try if cotangent of x were -2. Then if we found its reciprocal, which is tangent of x, we'd get 1 over -2, which is -1/2. So hopefully you can see what's going on here. If cotangent of x is negative, then tangent of x will be negative. In both cases, we start with a negative, we end with a negative. And that's just from the fact that if you ever take the reciprocal of a number, if it started positive, it'll finish positive. If it started negative, it'll finish negative. So that means cotangent of x being greater than 0 is the same thing as saying tangent of x has to be greater than 0. So now let's go to our chart to see which ones fit. In quadrant 1, all trig functions are greater than 0. They're positive, which means that fits. Tangent of x will be greater than 0 in quadrant 1. Now, let's check if any other ones will work. In quadrant 2, only sine is positive. And in quadrant 3, tangent is positive. So again, we want to use quadrant 3. So that tells us where sine of x is less than 0 and where cotangent of x is greater than 0. Now we just have to find what's common between these two choices. Notice we have a quadrant 3 in both of them. So we'll list quadrant 3 out. And now in the first one we have quadrant 4, and in the second one we have quadrant 1. Neither of those match up, which means the only common area is in quadrant 3. So that tells us that X is in quadrant 3. Now we're going to move on to the second part. We want to find where secant of x is less than 0 and where cosecant x is greater than 0 at the same time. So secant of x being less than 0 means that cosine of x has to be less than 0 as well because it's the reciprocal. And cosecant of x being greater than 0 means that sine of x has to be greater than 0. Remember, if secant x is less than 0, then its reciprocal cosine has to be less than 0. If cosecant x is greater than 0, then its reciprocal sine of x has to be greater than 0. So now let's go to our table. We have cosine of x in quadrant 1 is going to be positive because all trig functions are positive in quadrant 1. And now if we move over to quadrant 4, cosine is also positive. Oh, I apologize. We want where cosine is less than 0. So we actually want the opposite of those two. We want quadrant 2 and quadrant 3 because, like we just said, in quadrant 1 and quadrant 4, cosine is positive. So we want to do quadrant 2 because cosine is negative there, and quadrant 3 because, again, cosine is negative there. Now we'll move on to our other one. Sine of x being greater than 0 means just over here we have all the trig functions in quadrant 1 are greater than 0, so we'll put a quadrant 1. And then in quadrant 2, sine is greater than 0. We want that one as well. But in quadrants 3 and 4, only tangent and cosine are positive, so we ignore both of those. And now, just like before, we want to check what's common between these two choices. So here we have quadrant 2, and here we also have quadrant 2. So we say that x is in quadrant 2. And now we check if there's any other choices that match up in both cases, but we have a quadrant 3 here, a quadrant 1 here. They don't match up, so x is only possible to be in quadrant 2.